So I hope everybody and their family is healthy, and we're going to try this out and see what happens. Remember, you can always email me later if you're having a question. I'm going to go a certain length. I haven't really decided where I'm going to stop right now. That doesn't mean I expect this all to get done in one day. It'll just be a place that I decide to stop talking, and then you guys got a week to get this taken care of. Probably, if you're looking at the book, I'm going to stop at 33 with this video and add another video. I'll try to add another video for Wednesday. But again, you don't have to get it all done until I'll start the new section on Monday, next Monday. So we're talking about inverse trig functions, and so I just want to remind you of a couple things about inverses. And basically, an inverse is just when we switch the x's with the y's. And I'm just going to read out of the book here on a couple things here in a second. But that also means that a function has an inverse if that function can pass the horizontal line test. And so if you're looking at, this is just sine here. If you're looking at this, it would actually fail the the horizontal line test. I hope I said horizontal there a second ago. Because we are dealing with periodic functions here. And again, what a periodic function means is that it keeps repeating over and over again. And so the only way we can deal with an inverse when we're talking about trig functions is if we restrict the domain. And one of the things that's going on is that all of these trig functions restrict the domain in different places. And so looking at sine here, they restrict the domain from negative pi over 2 to pi over 2. And you can see that all of the values are going to get hit when we're talking about the y values, right? Sine oscillates between 1 and negative 1 continuously. And if you look at just this black part, every value is going to be hit there. And it also passes the horizontal line test all over the place. Now there's some things that are going to be in the book, and if you have your book with you, you can follow along, but I'm just going to read out a couple things and kind of show you on the graph here. It says, on the interval from negative pi over 2 to pi over 2, the function y equals sine of x is increasing, right? And so, right, you would agree with that, right? As we move along that interval, the function is always increasing, always going up when you're looking at the y values. The second thing that they're pointing out is on that same interval, y equals sine of x takes on its full range of values from negative 1 to 1, and that's something I already said. So, right, we're not missing any of the values here because then they just start repeating, right? Once we start going down here, all of these values just start repeating all the way down. So all of our values are being hit, all of our y values are being hit on that interval. And of course, you can tell, and I've already said this, that on that interval, y equals sine of x passes the horizontal line test. And so, right, sine has an inverse on this interval. So there's two different ways that we can write inverse sine, and they are interchangeable, and you'll see during the problems that you work out or in any other text, you'll see them used. And just so you know that these two statements are equivalent. So that's read arc sine of x, or you would also see y equals inverse sine of x. Okay, so those do mean the same thing, and you do want to understand that and not get confused that we're talking about anything else. So I just want to make sure everyone's on the same page here. Since we're talking about the unit circle a little bit again, and since we've restricted our domain for sine, and this only applies to inverse sine here, then we're only looking at values on this portion of the unit circle. right? This is, right here is negative pi over 2, right? Because that's, we've been calling it 3 pi over 2, but really it's negative pi over 2 for our cases here. And up at the top, this is pi over 2. So those are our only ones, right? And so when we're looking down here, we're starting here at negative pi over 2. So we're looking at these values and going around, right? Remember, this is just a different way of looking at the unit circle. So since we're thinking of inverses now, we're going to start off with a couple very straightforward ones. Okay, and so if we're talking about this coordinate, let me get my pen here. Right, if we're talking about this coordinate here, on the normal sine, we would say that our x is pi over 2 and our y is 1. But again, now we're doing inverses, and I'm going to show you a graph, and all this stuff is out of the book again. And so remember, an inverse is just where we switch the x and the y values. So when we're talking about the inverse at that coordinate, we're going to be talking about 1 and pi over 2. Okay, so I hope that all makes sense. Okay, so this is again, out of the book, the definition of an inverse sine function. And I think this is a little confusing, and so to me, this note at the bottom is where it really starts making sense. But right, they're saying it's defined by y equals this arc sine of x if and only if the sine of y is equal to x. Okay, and I don't know that that makes a whole bunch of sense until I show you a couple of example problems. But they're saying where our domain now, right, is now it's negative 1 to 1, which was our old y values from that previous slide. And now our range, right, our y's here, are from negative pi over 2 to pi over 2, which was our old domain. Okay, and so then the domain of y equals arc sine is negative 1 to 1, and range is negative pi over 2 to pi over 2, which is what we just said. So what this is saying is, to me, this is like the important part down here. Okay, so the arc sine of x is the angle whose sine is x. Okay, so let's go back here for a second to the example I just had, which was the sine of pi over 2 equals 1. So what we're saying now, according to this definition, is that the arc sine of 1 equals pi over 2. Okay, so, oops, I missed my C. Arc sine of 1 equals pi over 2. Okay, so, here's how I read these. So again, we'll do a real easy one here. So let's say we're doing arc sine of the square root of 2 over 2. Okay, remember, it's very important to remember that we're being limited to the right half of the unit circle when you're thinking of these. So don't get carried away and tell me that there's two answers on this one, because there's only going to be one. And so the way I think about this is, what angle, or let me re-say that, the sine of what angle gives me radical 2 over 2. So if you're thinking of your unit circle, right, you can remember hopefully that 45-degree angle, the coordinate up there was radical 2 over 2, comma, radical 2 over 2. Remember, sine is referring to the y angle, the y value. So which angle is giving us the sine of which angle, the sine of which angle gives us radical 2 over 2? Well, then that should be pi over 4. Okay, so, this whole definition is a little cryptic, but all you're saying to yourself is the sine of what angle, or, here in a second we'll do the arc cosine. Okay, so then when it's the arc cosine, you would say cosine of what angle produces this thing in the middle. So, again, I'll say it again. So, the sine of what angle gives us radical 2 over 2, that's up here, so pi over 4. The question could have been a little bit different. Like, so for instance, maybe, here, let me get rid of all that. Okay, so we'll stick with sine here. So let's say it's the arc sine of, we'll do negative 1/2. Okay, so we are, again, you got to remember your unit circle, we're down here now because we're talking about the y values since we're referring to sine. So the sine of what angle gives us negative 1/2? Okay, so that would be the sine of negative pi over 6 would produce negative half. So the sine of negative pi over 6 gives you negative 1/2. And that's going to be how all of these inverse trig functions work. Okay, that's the way you want to say them. So we can actually graph arc sine as well, since it is a function itself. And remember, this is only being able to be produced because we limited the domain on our original sine function. Okay, and remember, we're just talking about an inverse now. So all the x's and y's should match up. So, like if we're looking at the arc sine here, right, and we're going down, if we're up here at 1 pi over 2, you're just thinking, well, if we were talking about the normal sine, this coordinate corresponds to pi over 2, 1. Okay, so all of these are the same coordinates, right? Except now they're flip-flopped. The x's and the y's have changed. So if you were okay with everything about arc sine, then, like I said, all the inverse trig functions have the same idea. You just are changing the domain. You're restricting the domain of the original trig function in different places, but all of the things are basically going to be the same idea. Okay, so for cosine, you see that we end up limiting the domain from 0 to pi, and that works fine for us because, right, all of the values from 1 to negative 1 are being hit for the y values. Okay, the horizontal line test, this passes the horizontal line test since we've restricted it to just this area. So, and I'll show you some pictures here in a couple slides, but, right now, cosine, right here, if we're looking at this part, this would be cosine, right, let me write it out here. Right, so cosine of pi over 2 equals 0. Okay, and just remember, we're still referring to this unit circle idea here, and cosine is still x values. And so what is the x value at pi over 2 on the unit circle? Well, it's 0. Okay, and so, right, if you're understanding everything, you can say, well, then that means arc cosine of 0 must be pi over 2. Okay, and that's going to be true everywhere. Cosine of 0 is 1, so arc cosine of negative, so cosine of 0 is 1, so arc cosine of 1 is 0. Sine of pi is negative 1, so arc, I keep mixing everything up. It's hard to do it without writing it out. Cosine of pi is negative 1, so arc cosine of negative 1 is pi. Okay, so all the properties are the same. Or maybe not the same, but it's the same idea as doing all the ones with sine and arc sine. Okay, so here's the three major ones listed out with their domain and ranges listed. And, hopefully it makes sense, because remember that we're talking about right now the inverses of all of these. Okay, so again, arc sine is the inverse of sine. And so normally with sine, our range was negative 1 to 1. So now for arc sine, our domain is negative 1 to 1. Right? The range for cosine was negative 1 to 1. So our domain of arc cosine is negative 1 to 1. Okay, so these are all the values that we needed. With tangent, right, if you remember the tangent picture, the tangents look like that. Okay, so You know, for the original tangent, the range was negative infinity all the way to infinity, and so that makes our domain now negative infinity to infinity. Okay, and so then everything has been flip-flop, right? These are, notice that the arc cosine and arc sines have greater, y is greater than or equal to, where the range of the arc tangent only has less than. That's because with the original ones we had these asymptotes, and remember those asymptotes were at pi over 2 and negative pi over 2. Okay, so that's what all that means. So I think what you need to get out of this is that when people are referring to the inverse of these three trig functions, they're only on these domains and ranges, unless otherwise stated. Okay, and you've already seen a graph of arc sine, but there it is again. And then these are just the graphs of arc cosine and arc tangent. I kind of got my picture cut off there. But, if you're having trouble visualizing this, go ahead and sketch yourself a quick drawing of sine and cosine and tangent. Remember sine. Restrict it. It's kind of hard to see. Right, that's the sine one. Here is the cosine one. And again, the tangent one. Okay, and so, they all just match up. The coordinates match up. The x's and y's are just flipped. Okay, and so this will be the last slide before I do a couple example problems for today. Like I said, I think I'm just going to go to 33. I'm going to do the evens, some of the evens for you. It should be a pretty easy group of problems. I'm not saying that 1 to 33 definitely needs to be done. I guess I would do them before you watch the next video. You guys have a lot of leeway. Just try to get all questions answered and all problems attempted by Monday, and I'll have at least one more video for you. I do want you to get all the way to 97. And please ask if you're not sure about what I'm saying. But these are the properties. I want to point out that they're saying if your domain is from here to here and your range is from here to here. So, these don't necessarily apply outside of these ranges, okay, and domains. But, the way I kind of compare these would be like, I think everyone's okay with saying something to the effect of, well, the square root of x squared is just x. And, sometimes we refer to this as like, oh, well, these are opposites and they just cancel out. Well, they're kind of like inverses. These are inverses of each other in a way, right? And so that's how we get to x. And so that's all they're saying is, if you take the sine of the arc sine of some value, then you just get that value because these are inverse operations, okay? And so, right, that's what's going on. Now they just flip it because we're talking about the y value. So if you take the arc sine of the sine of a y value, you get the y value. Okay, and that's all they're saying is that these are inverse properties. And so they are just like every other inverse property out there. They kind of negate each other. Okay, so I got a unit circle on here, and I just picked out some of the even ones that deal with sine. And I did that just so that I can look at the same, we're only looking at these parts. We're only referring in our mind to the unit circle on that right-hand side when we're dealing with sine. Because remember, sine we had to limit from negative pi over 2 to pi over 2 in order for us to take the inverse of it. Okay, and so, again, negative pi over 2 to pi over 2. Okay, so again, arc sine of 0. What angle are we thinking about here? So the sine of what angle gives us 0? Okay, so right there is where y is 0. So the arc sine of 0 is 0. Right, 0 radians. And so number 10, arc sine of negative radical 2 over 2. So what angle are we thinking of? So the sine of what angle gives us negative radical negative radical 2 over 2. Well, here's where our y value is negative radical 2 over 2. You know, that's 7 pi over 4 on this, but we're not allowed to say that because that's outside of our new domain. Okay, and so we're saying it's negative pi over 4 is the answer there. Okay, and so one more. You know, what the sine of what, this is number 14, the sine of what angle gives us radical 2 over 2. So we're up here, so it's just going to be pi over 4. Okay, here's the two arc cosine ones, and remember, you know, our range is different on this one than it was compared to the arc sine. You know, our range on arc cosine, if you remember, is 0 to pi. So then we're only looking from 0 to pi over here. Let me get this out here. Yeah, there we go. 0 to pi. Okay, so what value, we're doing number 6 now. So the cosine of what angle gives us 0? Remember that cosine is your x values. So we're looking right here. So then it is pi over 2. Okay. Number 18. What angle, the cosine of what angle gives us 1? We're looking for our x values because we're talking about cosine. So we're right there. So then we're at 0. Okay, and so for the last group out of this section, we're looking at the tangents, and you know, tangent does not include these two points, but it's everything around the right-hand side again. And these are a little bit more difficult because you may not have remembered exactly this information, and maybe you had to do your simplification. So you can still work through it, and I'll work through it in that way. But again, we're thinking to ourselves, the tangent of what angle gives us negative 1? Okay, and so like if you're looking at 8, 12, and 16 here, we have two of them that are negatives. And so that means and remember that tangent is the like sine over cosine or y over x. And so if we're talking about the negative areas, then we've got to be down here for 8 and 16. Okay, so number 8, tangent of what angle gives us negative 1 over 1? No, I'm sorry, gives us negative 1. So again, we're doing the y's over the x's. And hopefully you think about these coordinates right there, because that would be, if I have enough room here, negative radical 2 over 2 over radical 2 over 2, and that gives you negative 1. So then the answer here, again, it looks like 7 pi over 4, but we're calling it negative pi over 4 so that we stay in our range there. Okay, so we might as well do 16 at the same time since we're already down there. So, tangent of what angle gives us negative radical 3 over 3? Okay, well, so remember we're doing y over x, and so really you got to be thinking of either this angle or this angle, and maybe you don't do it right the first time, but y over x, so if we said, well, negative 1/2 over radical 3 over 2, this is your keep, change, flip thing that you guys like to say, so this would be negative 1/2 times 2 over radical 3, which would be negative 1 over radical 3. We end up rationalizing like that. And so then there is our negative radical 3 over 3. Okay, so then we are at negative pi over 6. Okay, and hopefully I left enough room here for arctangent. Yeah, change the color up. The arctangent of radical 3. Okay, so the tangent of what angle gives us radical 3? We're up in the first quadrant now because we're at the positive here. And you're thinking, right, y over x. So radical 3 over 2 over 1/2, right? Keep, change, flip. Boom, boom, boom. And that would give us radical 3, okay? And so then I was choosing this coordinate up here, so we're saying that the answer is pi over 3. Okay, so 19 to 30 there, they're telling you to use a calculator to approximate the expression. Keep forgetting my C. Arc sine, there you go. So this is, you guys have used this button on your calculator before. Most calculators that I know of do not use arc sine, arc cosine, arc tangent as a button. They have this. They have this button for sine, you know, obviously cosine and tangent. Okay, so you guys have used this before when you're dealing with the right triangle stuff, when you're looking for the missing angle. So it's all the same idea, right? When we had the right triangles before, right, and you were looking for this, you know, and you had something like this, right? Depending on what you had, you were using, you know, inverse sine of theta. Sorry. So you were saying inverse sine would be, right, this is SOHCAHTOA, so opposite over hypotenuse gave you that missing angle. Okay, so, you know, this is all the same. And so all we're doing here for this set of problems is just typing it in, right, and hitting enter and rounding it to two decimal spots. And, you know, 31 and 32, this is just about understanding that the x's and y's are switched. So, you know, you're just matching it up that way. So I think you guys are smart enough to figure that out. Otherwise, if you're having troubles thinking this through, you got to ask some questions, please, please, please. And then 33, they're asking you to graph it on your graphing calculator. And since I just said that, I understand that you guys mostly were using those TI 84s, I think they were 84s, or 83s, whatever they were, in the classroom. So if you don't have your own, this is the time that you need to download some kind of graphing calculator on your phone. Okay, so Desmos I like a lot. It's an easy one to graph with. I know some people in class have been using Calculator X, I believe is what it is, and that's fine as well. But what they're asking you to do is to restrict your domains properly and graph both functions. And they're saying, you know, verify that geometrically that G and F are inverses. And so what you're wanting to remember here is that, hold on here. Is that you know, for instance, if you have the sine, oh, this is going to be hard to draw. Okay, so inverses are flipping the x and y, and so what that means is that they reflect over that y equals x line. And so then arc sine, if that's, I'm going to try to draw this, right? So if that is sine That's a pretty good try. That would be arcsine. Okay, and so all they're saying is, with the tangent, go ahead, put them in there, restrict your domain, and you can do that in the window. If I assume calculator X is the same. Desmos, you have to go, it's on the screen with the graph, and so it's like a little wrench, I believe. And you click on that, and you can play around with your window on that as well. And so you can just restrict your domain to look at it, and all you're doing is saying, hey, look, that reflects over the y equals x line. And you can throw the y equals x line in there to verify, and hopefully that makes sense. So that's, this stuff isn't really that bad, and really you've seen a lot of it before. So that should be a pretty easy group of problems. The next video I make will be starting at 35 and on. Please, if you didn't understand this, please ask. I will be available all day tomorrow. I'm not sure exactly how the Google Hangout, the video stuff is going to work. I know that there's a lot of things out there that I can try, but we're going to try the Hangout first. If that doesn't work, we'll kind of move ahead and try something else. And we're going to make this work. So please, if you're on the Hangout already, that's an easy way to ask a question. I think you should be able to post pictures on that. So if you haven't signed up for the Google Hangout yet, please do that. You can either email me a picture of what you're getting stuck on, and I can answer questions like that. So I should be available between 9 and 2 tomorrow, which is, that's going to be true every day for you guys. So just any kind of question that you guys have, please email me or put it on the Hangout. Either way will work for me.